Hi everyone, I am Pravlika. My new ID is TN567. In this video, I am going to explain about my large scale data structure assignment 3. This is the command which I have used to run the part of my code. Firstly, I have read the subject and query dataset into my memory. Subject data is read in chunks in order to improve the performance and to easily handle the large datasets. I have also created hash tables using the query dataset. These hash tables are of different sizes, which are of 1 million, 10 million, 30 million, and 60 million. I have also used a hash function which converts each of 32 character sequence into a unique hash value. Um, I, I have also calculated the number of collisions occurred uh, within the different hash table sizes. Here we can see as the size of the hash table increases, the number of collisions has been reduced. I have also calculated the time taken to populate through the hash table of different sizes. Here, time taken to populate for hash table of 1 million elements is of 92 seconds. Time taken for 10 million elements is of 97 seconds. And time taken for 30 million elements is of around 99 seconds. Time taken to populate through 60 million elements is of 100 seconds. As the size of the hash table increased, the time taken has also been increased. From the above um, timing results, we can say that there has been consistent increase in time as the number of elements increases. The increase in time is also not linear, which also indicates that hash table indicates uh, effectively handles the large data sets. Uh, the timing results also represents the capacity of hash table to distribute the entries more evenly, uh, which likely reduces the occurrence of collisions. Um, it also the timing results also implements shows us the efficient implementation of hash table in managing large data sets and maintain the balance between insertion time and collision handling. This is the command which I have used for part B of my code. Here I have calculated the time taken to search for all 32 character fragments. So it took me around 2.31 hours to search for all the 32 character long fragments of the subject dataset within the query dataset. I have also uh, ca- calculated the count of all 32 character long fragments. I have also displayed the first 10 fragments of the subject dataset that I have found within the query dataset. So while coming to my code, this is my header file. Here I have used a class name hash node. It handles the entries into the hash table. It stores the 32 character sequence and a pointer to the next node. I have also created a class named queries underscore HT. This queries HT class handles the operations that are to be performed on the hash table, such as inserting into the hash table and searching within the hash table. I have also created a constructor and destructor for the queries underscore HT class. I have used a hash function named getRadix, which takes each of a 32 character sequence and convert it into unique hash value. This is about my header file. While coming to my main file, I have read the subject data by using read subject data function. I have also displayed the subject data by using print subject data function. I have also created an object for queries HT class for different hash table sizes. I have inserted the sequences into the hash table and calculated the number of collisions and time taken to populate through the hash table. I have also, while coming to the search operation, I have calculated the time taken to search for all possible 32 characters. I've also displayed the first 10 32 character long fragments that are found that are of my subject dataset, which are present within the queries queries and HT. While coming to the hash search operations in hash table, the average time complexity for search operations is of a big of 1 by using a hash table. Um, it also indicates that we can easily retrieve a value without needing to traversing through all the elements, unlike linear and binary search, which are used in my homework too. In before in homework 1 and homework 2, we have used arrays and sorted lists. Uh, Linear search operation takes about big of and time complexity. Also, if we use binary search, it takes around big of log and time complexity. But here, by using hash tables, we reduce the time complexity to big of 1. So time taken to for performing a search operation is reduced by using a hash table. Also, while coming to the challenges I have faced, I have gone through memory allocation issue while dynamically resizing the uh, query, while dynamically resizing the subject data. I have also gone through issues with my hash function to make sure it efficiently distributed the entries and reduce the collisions. I have also gone through issues with the search operation to make sure it effectively compares a 32 character long sequence. One of the optimization technique I have used is I have pre-computed the I have improved the efficiency of my hash function by pre-computing the powers of a base modulo the table size. Uh, by using the above optimization technique, I have also reduced the overall computation time. I have also used a linear linked list structure, which also helped me in efficiently maintaining my insertion and managing my insertion and search operations within the hash table. So these are the optimization techniques which I have used. Thank you for giving me this opportunity.